Happy day.
Hello, Miss Jenkins. I hope you're having a good day. All the class says hi to their friends.
Hello.
Hi.
Make sure to follow
Very
me.
non-energetic,
Subscribe.
non-energetic, but whatever. They said hi.
Is my hand in the shot?
Okay, so we're gonna start 5-2.
Shot?
I'm talking. We're gonna start 5-2, so open up your books to section 5-2, please. 5-2.
263.
263. Actually, go to 264. We're gonna skip the solve and discuss it. So go to 264, example 1.
This is very disorienting.
Are we good? You're there? Okay, so now we're gonna go back to systems of equations. Yesterday was a review. We'll get back into systems of equations. Somebody tell me, what is a system of equations? Give me a brief definition of it. Sasha, do you know?
You scared me for a second.
Nobody can give me a definition?
Of what?
System of equations.
The order of equations you do, like it's multiply, divide, and then subtract.
That's order of operations.
PEMDAS.
It's formed by two or more linear equations that use the same variable.
It's two or more linear equations
Great job,
that use
Mimi.
the same variable. So the other day on Tuesday, your first day back to school, maybe your brains weren't working yet. That's why you can't remember. I'm not sure. But we looked at them on Tuesday, and you had 3 different options for solutions when you had a system of equations. And Tuesday was based on what kind of a solution do you have? What were your 3 options? All of your homework on Tuesday was, is it this, this, or this?
Oh, I know what they are. You should ask
What's
Jackson.
one of them, Zach?
No solution.
No solution is one of the options. Siri?
Infinite solution.
Infinitely many solutions. Dro?
Exactly one or just one solution.
Exactly one solution is the third option. Okay, so on Tuesday you were just deciding what kind of solution do you have. Today you're actually going to be finding those solutions and looking at them. And we're going to do it via graphing. So let's get started with the video.
How can graphing help you solve a system of linear equations? Think about this question during the lesson. Lee is choosing a new cell phone plan. She has narrowed it down to these 2 plans. How can she use the graphs of a system of linear equations to determine when the phone plans cost the same? Which plan should she choose? You can use the graphs of a system of linear equations.
Okay, I'm going to pause it because I want to make sure you know what these little flyers here mean. Because 1, you probably don't pay your cell phone bills. 2, they're probably not charged like this anyways. Usually you just have an unlimited plan and you pay $60 for your unlimited plan. Like it's just a flat fee that you pay.
But they like.
This is a little,
Oh, that's how ours is. That one.
is it?
Yeah, we have to pay so we have a certain so it goes for like a month, I guess, and then we have a certain amount of data in that month that we can use.
Oh,
And
yeah.
if you go over.
Yeah, then it makes us pay.
Yes, yes. So some plans work like this, like if you can only use so many minutes, like there's a cap of how many you're allowed. If you go over, you have to pay so much per minute that you go over.
And
It's usually a lot.
yeah.
Like it's not good if you go over that. If
It's
you
like
have just
$15.
unlimited, this wouldn't apply to your bill. This is how home phones used to be all the time. So when I was growing up, everybody paid on their landline phone per minute. Like you had to pay so much for every month, but then you had to pay for every one of the minutes you used. So this one here, you have to pay 20 cents for every minute. You think about that, that's a lot. You only have to talk for 5 minutes and you're paying $1 already. That's a lot, I think. Plus $75. Are you with me? Okay, unlimited data. So data doesn't count. We're just talking about phone calls, I think, here. This is your price for your phone calls. I would assume the $75 covers your unlimited data. That's that part. Yes? Okay, what about this one? Describe to me how this one works. Christian.
So it's 25 cents per minute, and like when you start, it costs $70.
Okay, so what's the $70 most likely for?
The
The unlimited data.
That's your data cost, and then it's 25 cents per minute for your talking. Who would want to use plans like this?
No one.
Well, I mean, maybe,
about the country.
maybe.
People that don't use phones a lot.
I would say people that don't call very often.
That's
Yeah.
me.
Yeah, if you
No
don't
one
make
calls
phone
me.
calls and you're just getting the data, this wouldn't be too bad because you're not, the 25 cents per minute really isn't gonna count if you're not talking very much. Okay,
No one
here we
calls
go.
me.
To compare the cost of each plan. Let's begin by writing a system of equations. Her total monthly cost of a plan is equal to the cost of the number of minutes she uses plus the cost for unlimited data. Let X equal the number of minutes used each month. And let Y equal the total monthly cost of the plan. The equation for company A is Y is equal to 20 hundredths times X plus 75.
Okay, 20 cents
The
per
equation
minute
for
plus
company B
$75.
is Y is equal to 25 hundredths times X plus 70. This is our system of equations. Now, we can graph the system of equations.
Okay, so we're gonna graph each of these separately. How do you graph the first one? Rachel,
Start at that y-intercept of 75 and
Okay.
then go. Oh, sorry.
keep going.
Oh, and then we would probably want to change it to a fraction because that'd be
Yes.
easier. So it'd be either 20 over 100 or just do you could do 1/5.
You could do 1/5. This is the same thing as 1/5. If you made it 20 over 100, that simplifies to 1/5, so you go up 1 over 5. What about the second one? What about the second one drove?
You'd start at 70, you'd convert 0.25 into a fraction, and then that would equal 1/4. So up 1 over 4.
Up 1 over 4. Very good.
Use the slider graph.
Next.
There was no graph.
Okay,
Okay.
here
The
it is.
lines
Here it is.
intersect, so there is one solution for this system of equations. What does the
Okay, so we skipped a little bit because it wasn't showing up there. So the blue line, that's not blue at all.
Purple.
I was
That's
say
purple. So the purple line is company B, the green line is company A. If you were to use, they're gonna talk about this, but I'm gonna jump ahead a little bit. If you were to use 0 minutes, if you were never gonna call on your phone, which plan would you wanna go with? Which plan costs the least if you're gonna use 0 minutes of calling? Trevor?
Company A? Because, no?
You go to 0, do you see where these two are here? Which one's lower?
Oh, company B.
Company B would be lower, right there. The cost is less for the purple line than the green line right there. But if you were gonna talk a lot, and you were gonna talk, let's say 300 minutes,
Oh, hey, sus.
300 minutes, which one is lower?
Company A.
Company A is lower then. Okay, so it depends on which side you're on the intersection, which company you would wanna go with. Rachel?
So is the company B lower because of where like you have to put down $70? So if you were to never call, you'd only have to pay $70, and the
Right.
other one you'd have to pay 75.
Correct, yes. That's why it's lower at the beginning. Yep. And this is their intersection point right here. It's at 195. So if you're gonna use 100 minutes, couldn't you be at either plan and still pay $95?
Yeah.
That's what this means. So if you're gonna use exactly 100 minutes, you could choose either of these plans and you're still gonna pay $95. That's their solution.
The intersection point, 195, show about the two cell phone plans.
You did it before.
Oh, I already did it. Yep. Keep going.
This intersection point shows that if Lee uses 100 minutes each month, both plans cost $95. She could choose either plan. If Lee uses less than 100 minutes, which plan should she choose?
We already did this, so we're gonna move on.
Select
okay?
your answer.
Select your.
We're gonna move to the next one.
This the try.
Okay, so you have a triad in your notes. Do you have a coordinate plane there also?
Yes.
Perfect. Okay, so we're all set to go. For the first equation, we need to graph it.
Well,
For the second equation, we need to graph it. How do we graph the first one? Somebody quickly talk us through. Jackson, why don't you help? Did I call on Jackson again?
No.
Sorry, Jackson, you get called on twice.
Sasha.
Oh, Sasha. But she didn't know the answer.
Doubt it.
Remember? She didn't say anything. I don't know.
Goodness.
Just kidding.
Neither
How do we
does
graph the first one? Rachel, you just answered email.
Start at 5.
Okay, start at 5.
Then go up 3 over 1.
Okay, we'd go up 3 over 1, but that's going to be way off our graph, so how could I do that to stay on the graph? Remember how to go backwards? Email?
Go down 3 over 1.
Down 3, left 1.
I was on a different triad.
Oh, you got to be on the right triad.
Come on, Caitlin.
Be really careful with your lines, because remember, we want to see where it intersects with a different line, so you got to be real accurate or you won't know where your intersection point is. Okay, second one, y equals 2x plus 4. Caitlin, how do I graph 2x plus 4?
I start at 4.
Okay, I'm gonna do a different color. Okay, start at 4.
Yeah. And then you go down 2 over 1.
Over right or left?
Left.
Left, if we're switching direction, so it would be up 2, right 1, we're gonna go down to left 1.
Oh.
Did you find your solution already?
Yeah.
Hold up, it's on the same one.
Don't they share a point when you're graphing them?
Yes. Miss Sugargreen,
Ma'am?
which one do you always know that goes first? Does X
Doesn't.
always go first?
What do you mean?
In that.
Oh, X always goes first, yes.
Okay.
Yep. So here's our intersection point right here. It's the only point that you had a green dot and a blue dot at the same point. So that's our solution. It is at -1 on the x-axis, 2 on the y-axis. So -1, 2 is our solution. -1, comma 2 is our solution.
Oh, because that was what
I feel like the other shoes are in
That's it. That's it. That's our solution right there. We found a solution.
because that's where they met.
Yep. Yep.
There's 2.
There will never be. So Siri's question was, what happens if there's 2 intersection points? And that's not one of the options, because remember, our options are exactly one solution, no solution, or infinitely many solutions. Those are the only 3 options you'll ever have. Yes, yes.
But this is one solution, right?
That's one solution, yep.
Unless it's usual or whatever. If it was not a straight line, but
Oh, yeah, but we're not gonna look at any of those, not yet.
Oh, what line?
parallel.
Oh.
Okay. So we have a system of equations here. The first one, you know how to graph that, right? X minus 4, how would I graph it? Hannah, how would I graph x minus 4?
You go down 4,
Down 4,
and then you go up 1 and over 1.
up 1 over 1. We got a slope of 1 right there. There it is. So it starts at -4, up 1 over 1, up 1 over 1, up 1 over 1. So there's the first graph. What about that second one? What's wrong with this?
Oh.
Christian?
It's in an equation form. It's not in the correct form. You gotta work it out.
It's not in y equals mx plus b. So we're going to take this equation and solve it for y. So to solve for y, you have to get rid of the 2x. So you have to subtract 2x from both sides.
They didn't even do that. They just like put it on the graph anyway.
Notice everything has subtractions in front of it because you've got a -2y, so I still have a minus in front of it. I have a -2x, so I get keep the negative in front of it, and I have a -2, so I keep the negative in front of it. Everything has negatives.
Stop being so negative.
In your workbooks, they don't have this worked out, so I see a lot of you writing it. You might want to, just because they don't give you the work for this.
This is weird.
Yeah, that is weird.
Fine.
How?
Okay? I still don't have y equals, right?
You just changed the
So
word.
Irene, what else do I do? How do I get rid of the negative 2 in front of it?
You.
Ooh, emails.
Yeah. Connie.
No! Irene!
She said that?
Okay, phone a friend, email.
Divide by -2.
Divide by negative 2. Okay, so y equals negative 2 divided by negative 2 is going to give me a 1x.
An X.
Come on,
You can do it, boy.
there we go. And negative 2 divided by negative 2 is una. So we get 1x plus 1. Now that's in the right form. I know my y-intercept is 1 and I know my slope is 1. Now I can graph it.
What the flip is your boat?
Sorry, they just put some work up there over my writing. So we've got 1, up 1 over 1, up 1 over 1, up 1 over 1.
Basically, that's kind of weird.
So if you look at these two together, which is what you see in your workbook, where do they intersect?
Nowhere.
They don't. So this is
No solution.
no solution. There's no intersection point, which means there is no solution to this. Given, when we solved the equations, what was the first one? Y equals x minus 4?
Yes.
And then when we solved it, we got x plus 1?
Yes.
How do you know from this that it's going to be no solution? This is what we're working on Tuesday. How can you look at just this and decide you've got a no solution system? Siri, for what? Okay, so you have different y-intercepts. They start at different places, but their
Have the same.
slopes are the same. That was the key for a no solution problem. Same slope, different y-intercepts. What if they had the same slope, same y-intercept? Rachel? Infinitely many then, yes.
Solution.
Yeah, put it right on there. Okay. Do I have to do any work to the first one?
No.
No? That's in the right form, right?
Yeah.
What about that one?
That's not in the right form.
Not in the right form.
Of course.
So I'm gonna leave that one, I'm not gonna do anything, but the second one I gotta go through and solve it, which you might want to as well in your workbooks. So we have negative 3x plus 6y equals 18. How do I begin solving that for y? Irene,
You would add 3.
perfect. We're gonna add 3x to both sides. So that goes from the left side. I have a positive 6y, so I'm gonna write that as 6y equals positive 3x, and that's a positive 18. So everything is plus when I do that. What else do I have? Caitlin,
You have to divide by 6.
divide by 6.
I was thinking that it's not on our paper, so I was wondering what they were doing on our paper.
Oh, they're writing it. They're just writing down this work.
Where did you get that?
Where did I get the 3x? It was over here and I added it to both sides.
Oh, okay.
That's where that came from. So I got 3x plus 18 on the right. Now everything gets divided by 6. 3 divided by 6, how would I write that, Email? 1/2. Good. That's 3/6, which simplifies to 1/2 x. And 18 divided by 6 is 3. So I have that equation as my second one. And I have that equation as my first one. You should be able to tell me what my answer is even before you look at the graph. Christian?
It is infinitely many solutions.
Infinitely many solutions. These are going to be the same exact line.
I'm so sorry.
Okay? So if I graph it, that's what it looks like. You have one line right on top of the other line. Infinitely many solutions. Okay, so I want you to do the try it for example number 3. Do you have an A and a B?
Yes.
Okay, you're gonna have to use,
Both of them are wrong.
they're not the same?
No,
Amen.
no, I'm saying like both of them we have to
Oh,
solve.
yeah. And I'm just gonna have you do just A.
Oh, thank Jesus.
Just A. But neither of them are in Slope-Intercept. Neither of them are solved for Y, so you gotta do some work. Oh, it should be 5x minus 5x. So it's not gonna be negative 8. It'll be negative 5x minus 3. Because they're not like terms, you can't add them together.
Wouldn't it be, wait, could you do negative 3x minus 5?
You could.
Okay.
Oh, no. The x has to stay with the 5 though.
Yeah, I know.
Oh, okay.
Slipped
Yeah.
up.
You still subtract this, right?
Well, you can't subtract them because they're not like terms. So you'd have y equals, down here, write y equals, and you have a negative 5x minus 3. And there's your equation, yep. So go ahead and try the second one, the 10x one.
Is that what it would look like?
And then minus 5x. So you got your negative 3, but you also need a negative 5x. So your slope is going to be negative 5. Your y-intercept will be negative 3.
Okay. Hopefully I get negative 4.
Do we graph when we're done or no?
Yeah, graph it when you're done.
It's just like
Do you want me to help you with the equations to make sure yours are right?
Does a 10 look like... Come on, man. We can do hard things.
Let's check the equations just to make sure they're right before you get your graphs going. For this one, what did you do first? Zach?
Subtracted 5x from both sides.
Okay. Okay, so y equals, there's a few people having trouble with this side of it, like you're wanting to make that a negative 8 and combine them, but they're not like terms. You can't do that. And in slope-intercept, it's y equals mx and then b. So usually I put the x term first, and then the number second, so that it's in the right form, the form you're used to reading. So that should be your first one. Rachel?
Then you have to divide, so there's a invisible 1 right there.
Okay.
So we would divide 1 on both.
But if we don't see a 1, do we have to divide by it? Because divided by 1 isn't gonna do anything,
Oh, yeah.
right?
Yeah, so it's already there.
So there.
Yay.
Good job, Rachel.
We all need slow clap.
Oh, yay, thank you. Okay, next, 10x plus 2y equals negative 6. What did y'all do first? Caitlin?
You subtract 10.
10?
10x.
10x, there we go.
I think I did more work than you did on that one.
Come on.
Okay, so 2y equals, well, how am I gonna write this? How do I write this part of it?
Uh-oh.
Drove.
Negative 6 minus 10x.
Okay,
Or
you can do negative
vice
6
versa.
minus 10x, but I like to put the x first, so I got my slope first. So I will have negative 10x,
Come on. God, that bothers me so bad.
me too, minus 6.
Yeah, I did that one.
And you also, this one does have a number in front of it, so we have to divide this one by 2.
Yeah, I did that part right.
So y equals
Oh, the,
What it?
negative 10 divided by 2 is gonna be negative 5x.
Looks like you're trying to do some sort of magic.
Okay, I'm gonna write up here. Y equals negative 10 divided by 2 is negative 5x. Negative 6 divided by 2 is minus 3. What do you notice between the red and the purple?
They're the exact
They're the
same.
same. So how many lines will you end up having on your graph?
One.
Only one of them. So go ahead and graph that one line. You feel like you did it wrong? What's your question?
Since we're talking about graphs, if there's a negative, since we already know it's
Mhm.
negative 5x, and you go, normally you would go
Down.
down, so would we go up since
You
there's
would.
nothing to
Okay.
go down?
So we're gonna start at negative 3. But we're supposed to go down 5, right 1. Because remember there's the 1 underneath here. But I can't go down 5, right 1, so I'm gonna go up 5, left 1.
Left.
Yep. Because you want a negative slope, so make sure your line is going down when you draw it.
Your graph is large enough.
What?
Your graph is large enough.
Yeah.
Bang, I did it.
Oh, now I feel bad.
That's a pretty great line. Just so you know. I want everybody to acknowledge my line.
It's a little bit off.
A little bit.
It's only going 4 up and up.
But it's pretty great.
It's, oh.
Everybody's a critic.
Yes.
No, just
beautiful.
Is there homework online?
Remember when Mr.
Please
Kogel-
say no.
Mr. Kogel drew the perfect circle and he didn't erase it for like a week.
Miss
Yeah, I remember
Sjogren
that.
is the Gordon Ramsay of drawing lines.
Oh, Gordon Ramsay's hilarious, I swear.
No, he's a
Lance
terrible
one.
person.
No, I
He yells
love
at
him.
people.
I know, that's why I like him.
Okay, I want to do one more of these because we didn't get through one of these on our own, the word problem kinds. So it's not in your book. Take out your whiteboard markers. Yeah, these aren't in your book, so you don't have them. So
Is homework online?
no, it's not.
Yes. Never.
These graphing ones are hard online,
Oh,
so I'll have book homework for the graphing ones.
I liked the homework yesterday.
Because it was easy.
Because it was, yeah.
It was easy.
Wait, we had homework yesterday?
Okay.
I made the final.
It's gonna be in the book, so don't put that too far. Okay, Justin is choosing a new cell phone plan. If he uses less than 300 minutes per month, which company plan is going to be cheaper? So we're trying to figure out which company to go with, and we've got company A and we've got company B to choose from. Maybe. A little bit
We'll
better.
make estimates on
Okay, so for company A, it's 20 cents per minute and a $35 a month for the unlimited data plan. So how would I write that as an equation? 20 cents per minute plus $35 a month. How is that equation written? Christian?
Y equals 0.20 x plus 35.
Okay, good. 20 cents per minute plus $35. Company B, 15 cents a minute, $50 a month. Caitlin?
Y equals 15 x plus 50.
Okay, good. How can we turn the first equation so we have a good slope? What can I turn 20 cents into so that it's easier to graph? Ime? 1/5.
There's a way to do that one though.
In the second equation, how do I write 0.15 as a fraction so that I can graph it as a slope? How do you write 0.15 as a fraction?
Wait, what did you just do to that?
Oh, I turned this into 1/5.
Okay.
And I'll show you how on the second one here, because the second one's probably not one that we gotta work through it. How do I, somebody tell me, how do I say 0.15 correctly? Like if I wanted all the
15
math
times.
vocabulary, 1500ths, it's 1500ths. So this is 1500ths.
No, I can do some. I can go.
Yeah,
I know, but 1500ths is what it would be correctly. 15 and 100 can both be divided by 5 though, so this would become 3/20ths. If we simplify, we want to make it a little easier. We're going to draw a graph. How many quadrants will you need?
You'll need,
Rachel?
you'll need 20.
No, how many quadrants?
Oh.
Like 1, 2, 3, 4. Which
Only one.
we only need quadrant 1 because we're only going to have positive numbers for our bill and positive numbers for the minutes we use. So we're only going to have quadrant 1.
Oh, you have crazy wavelengths.
Yeah. What would I label my x and my y axis? What would the x axis represent? Lily, do you have a guess?
The x-axis for sorry.
You could. How many minutes?
How many minutes? Good. If this is 20 cents per minute, so x represents the number of minutes.
But you can't do cents per minute?
No, it's nothing to do with the cents. It's just the number of minutes I use. And what is y then? What is the answer to these equations going to give us? What is the y? Siri? No, because this is only for 1 month. If we were looking at it over many months, that would be right, but we're not. What does y tell us? If I do 20 cents times how many minutes I've used and add 35 to it, what's that answer going to tell me? Hannah, how much it's going to cost you. It's your bill. It's your ending money you have to pay for your cell phone. Now this gets kind of tricky because for company A, what's the minimum you're going to be paying?
$35.
$35. If you don't call anybody, you're still going to pay $35. What about company B?
$50.
$50. So do I want to start my graph at $0?
No.
No, that your bill's not going to be that low. For sure, I can jump up to $35, right? That's the minimum bill somebody's going to have. So I'm going to do a broken graph. You remember those little zigzag at the bottom there? And I'm going to start at 35.
But heartbeat, that dying.
Well, that's a depressing thought. Thank you.
A heartbeat that
This one's going to be tricky to graph.
Are we going to do it by 5?
Yeah, go by 5.
Let's count by 5s.
Instead of heartbeat dying.
No, a heartbeat that has.
Can we stop? I don't find it as funny as y'all did. Let's try to go to 65.
Oh, I went to 120.
Oh, your graphs you might have more space than I do.
Well, just because I did the small dots, like the small dots
Mhm.
between big dots.
Are we gonna do the, let me show you. If there's a graph, the one with the little squiggles,
Mhm.
or the dead heartbeat or whatever, anyway, so, the x-axis doesn't have to be, like, start at 35.
It doesn't have to, no. So for the x-axis, we're going to start with 0, but let's count by the same thing we did up here. So let's count by 5s on the x-axis as well. It's easier if you keep the same. You don't have to, but it's easier. They do have a really nice graph on here, so if ours is a little messy and we can't read it very well, we'll look at theirs to answer some questions. Oh, well. For something like this, you'd usually use graphing technology, like a computer or a calculator or something like that. So we're just going to look at an estimate here. So for the first one, we cross at 35. I'm going to circle this one in blue. so you guys can see. I'm gonna graph that one in blue. How do I do 1/5? How do I graph 1/5? Irene?
You go up 1/5?
You go up 1/5, but do I go up 1/5?
No. Yes.
I can actually go up 1 spot and over 5 spots. Because that's 5 over 5 spots would get me to 25, right? What's 5 over 25 simplified as? 1/5. So it gives me the same thing.
You go black law.
Mine's a big graph, so it's like, what the heck did you do?
It kind of looks like that. I don't know. It's not going to be very good. I just want you to get the general idea for now. I'm going to graph the second one in a green color. We're going to start at 50. My graph isn't even nearly big enough to see where they intersect, so this isn't going to work, but that's okay. 3/20. How are you going to do that?
Up.
We can't go up 3 spots and over 20 spots because
But
I don't
can.
have enough.
I can't.
Can you? If yours is large enough, you can. For mine, I'm going to go up 3, like an actual measurement of 3, which is only a part of a block,
Wait, why are you
And-
at 50?
because it starts at 50.
Oh, okay, I was like, what, 50? 1, 2, 3. So we just kind of guesstimated.
Yeah.
And then over 20. I have it on my own blue.
I can graph it, but it's just gonna be a very.
Which line is steeper?
So do we just go to 20? Or we
Yeah.
actually-
Wait a minute.
The first one.
Also move it over 20.
Wait, no, but we just go to 20 since I moved it up.
Company A.
Well, so draw a dot at 50, because that's where you start. Then you go up 3 over 20. You get a dot right there.
Like 2, the number.
Yes.
Yes. Yes.
Okay, so this line is steeper than this line, which means at some point, if you keep going, they will intersect out here at some point, right? Let's look at their graph to find it.
You show it in there, bro? Dang.
You probably went by tens.
Okay, here it is. So this is a computer-generated graph, which is much more accurate than our guess that we just had. Notice what they have on the x-axis down here. Much larger numbers to be able to go out further for the minutes. So if our question is, if they're gonna use less than $300 per minute, so here's 300, if he's gonna use less than that, which company should he go with? Which company is cheaper at 300 and less? Drove.
Company A.
This one right here, Company A. That's got the cheaper bill when you're under 300. What if you're going to use 300? Every month you are determined to use 300 minutes of talking.
That's
Rachel,
Either of them.
either one. That's where your intersection point is. So if you're right here, doesn't matter which company. But if you're going to use more than 300, then you need to go with
Company
Company B. Do you see how that's working? Yes? Kenzie, you got any questions? No, she doesn't. That's good.
Oh
Okay.
my gosh, we're talking a lot.
Okay.
Like, what is she talking
Your homework. Flip to. Oh, sorry. Erase your desks.
Can I use a tissue of somebody's? That's so embarrassing.
That does
Siri,
sound
can you
gross.
pass this to Trevor?
Oh no, Siri's got me.
There. Once that's done, take your books out so I can tell you where the homework is.
Oh man, homework.
He lives with a head shop. He does.
Is it the
For the whole year.
That's well, someone threw away my first.
Go to page 266 in your books. 266. Page 266 in your books.
I'll just add it to the next one. Very good. Carry it over to the next one.
266, let's go. Move it.
There.
Over here. Your homework is only 4 through 8.
What?
4 through 8.
Well, thank you. Thank you. Done.
You're gonna graph systems and equations, find the solutions.
When we turn it in, will we turn both pages in just the practice and problem solving?
I'm not sure yet.
Aw.
The graphs are some of them are too small for them.
They are? Okay, hold on. Have a good day. That was to them.